Hello, I'm Georgos Ganyas. I'm an MSc student and I'll be presenting our work comparing different grasping visualizations for object manipulation in VR using controllers. Object manipulation in VR has been extensively researched by the community as it is one of the most common actions in virtual environments. The main focus of these studies, however, has been camera-based or glove-based hand tracking, as these techniques can potentially feel closer to our real-world experiences. These studies have shown that users prefer realistic grasping visualizations without transparency effects and hand-object interpenetrations, while on the contrary, their performance is better when the tracked hand is being displayed. On the other hand, little to no research has been conducted concerning the effects of visual feedback for grasping in VR when the input device is handheld controllers. In this work, we address this gap by examining three different grasping visualizations when using controllers in terms of how they affect performance, sense of embodiment, and general user preference. We chose to exclude techniques that penetrate the held object or include transparency due to the nature of controllers that allows for explicitly expressing the intention to grasp an object via a simple button press. The grasping visualizations chosen are auto pose, simple pose, and disappearing hand. For auto pose, upon entering a grasping distance and pressing the trigger button, the fingers bend according to the calculated pose, which is calculated based on the object's shape and position at the time it is being grasped. Simple pose acts in a similar way, with the difference that the hand's pose is not generated during the grasping action, but it is always a closed fist pose that does not penetrate the object. Finally, disappearing hand is a very common technique that features the virtual hand being totally invisible upon grasping. In order to examine this visualization, we conducted an experiment with 38 participants, where each one had to test all grasping visualizations in a pick and place task. One repetition includes hitting the green button in order for the object to spawn. At this point, an object spawns in front of the table, either a cube, a pyramid, or a cylinder, with 6 indicators that represent the correct placement of the object on every target on the table. After grasping the object, 5 out of 6 indicators disappear, revealing the target for the task, and the positioning task starts. The user must now place the held object on the designated target as fast and accurately as possible. In the beginning, the users have to go through a brief tutorial phase where they test all visualizations. After this tutorial, 24 repetitions of the same task occur, with the users testing one visualization. When the session of these 24 repetition finishes, the visualization changes and the users have to repeat the session but with a different grasping visualization. This happens 3 times so that the user can test all 3 methods. At the end of each session, the participants were asked to answer a series of questions in the form of a semi-structured interview, while they were still immersed in the virtual environment. Additionally, when all 3 sessions finish, the users remove the HMD and are asked another 4 open-ended comparative questions in the form of a semi-structured out-of-VR interview. Throughout each session, 9 out of the 24 times, an obstacle appears in order to examine the user's behavior and performance change upon encountering them. These obstacles include either spikes that cover either the left or the right side of the objects, or obstacles that appear on the table. These consist of a brick wall obstacle, an electric current obstacle, and a barbed wire obstacle. And now let's see our results. In terms of performance, no grasping visualization stood out when no obstacles were present. However, we did find significant differences in the case of position error when the obstacles were present between auto pose and simple pose, with auto pose being more accurate. In addition to that, we can see that uniformly across all 3 methods, the selection duration of the objects was longer when spikes were present. This result suggests that the experimental setup in general was able to induce a sense of embodiment. For the sense of embodiment, our results also show that the autopose induced a higher sense of agency, as we can see from the answers on the questions that address this matter. In a similar way, the users reported a stronger sense of ownership, again with the autopose visualization. Inspecting the interviews conducted after the experiment, we can see that most of the users considered autopause as the most effective method. Also, the sense of vulnerability towards the spikes and the obstacles was higher with autopause method, two findings that support the stronger sense of agency and ownership respectively. In addition, most of the participants considered autopause to be their favorite method between the three. Apart from being the user's favorite, we can see that the users preferred autopause as it is considered the most natural method, also supported by the interviews. In the case of the most comfortable and fun method, there was no significant difference in the user's answers. Finally, the analysis of the interview results revealed trends on user perceived strong and weak points of the three methods. Autopause was characterized as realistic or natural by 16 users, while 5 commented that it was different from what they thought it would be, and 3 that they had less control. For Simple Pause, 9 users felt that it gave them more control, while 8 felt the opposite. Simple Pause was also characterized as fake or non realistic by 7 users. The strongest point of the disappearing hand was that you don't have to deal with your hand and you can focus only on the object and the tasks, according to 10 users, as well as that 7 users felt that they feared the obstacles less. On the other hand, 9 participants also commented that its main negative aspect is that you have less control because you cannot see where your hand actually is. In conclusion, from our study, we can infer that when using handheld controllers, the type of grasping visualization does not highly affect user performance during simple object manipulation tasks. However, our results indicate that the perceived sense of ownership and agency, as well as the user preferences, can alter depending on the grasping visualizations. It seems that more realistic and natural visualizations are able to create the illusion of higher levels of control and body ownership. Hence, grasping visualization is an important factor affecting user experience, and therefore further research is needed to explore its effects on different applications. Thank you very much for your time.